So, yesterday we have done some random functions, random choice, and few functions like converting to float, sprites, shape, array, and all, line space, arrange ones, zeros, all these functions we have done. So, the next set of functions that we're gonna do today. I'll be giving all the list at the last. Mhm. Reshape. So before we starting with reshape, today, first and foremost, we should import pandas and NumPy. Import pandas as PD, import NumPy as NP. So for you to work on with reshape function, first and foremost, let us consider a data wherein which I consider array A is equal to np dot a range. Let me consider some 8 values. So if I print A, it prints 0 to 7. But suppose if I say B is equal to A dot reshape, I want it to reshape in such a way 2 rows and 4 columns. Print B. It's a modified array. This is on a single dimensional thing. Suppose I consider A is equal to np dot array 1, 2, 3, comma 4, 5, 6. Make sure the braces close in a very perfect way. Then I say B is equal to np dot reshape A, comma 3, comma minus 1. So minus 1 is used to infer one of the dimensions, reshaping it in the format of 3 rows and 2 columns. Initially it's 2 rows and 3 columns. Now it will be 3 rows and 2 columns. Print B. Now let me consider the same array. Then I say B is equal to np dot reshape A, comma, you can even do 3, comma 2, comma, order is equal to F. This is basically Fortran order. Print P. It prints in such a way 1, 4. And then again, Fortran order in the sense, initially you have 1, 2, 3, 4, 5, 6, no? It prints 1, 4, 2, 5, 3, 6. That means in this way. Vertically it considers. Clear? Next. Hmm. Suppose I say A is equal to np dot array. I have 85. 90, 78, 92, 88, 76. Suppose these are my values. B is equal to A dot reshape. There are 6 values, 2 rows and 3 columns. Print B. This gets changed. Suppose if I say A is equal to np dot array 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12. Suppose there are 12 values. B is equal to A dot reshape, 2 rows, 2 columns, 2 arrays, 2 rows, 3 columns. 6 in one, 6 in another one. Next. The same about 2 rows and 3 columns. A dot, here let me consider A dot reshape -1. Print in a single dimensional, it gets printed. Group of values like this. 2 rows, 2 arrays, 2 rows. Columns is something that I have to decide as -1. When I decide as -1, by default, it would be considering it like this. This is the thing. So these are some reshape functions that we can do on an array. Got it? Hello, hello. Is that clear? Anything to be repeated over here? Next, flat. How do we flatten the things? Let me consider A is equal to np dot array. I'm considering 1, 2, 3, and 4, 5, 6. I say for I in A dot flat print I. Each and every element gets printed one after one after one. Suppose I say the same thing for I comma j, that means for index comma value in enumerate A dot flat. A dot flat of j I is equal to value into 2. Hmm. Flat. sorry, dot. So it prints for every, see, 1 into 2, 2 into 2, 3 into 2. Similarly, 4 into 2, 5 into 2, so on and so go. For all the values, into 2 value gets printed using the enumerate function. Now, the flat can be done with multidimensional or specific value. If you want first element gets printed, second element gets printed. In that way also you can do. How do you do that? Suppose A is equal to np dot array 1 comma 2. In this you have 3 comma 4. This list gets closed over here. 5 comma 6 comma 7 comma 8. Another open, another close. I say print A dot flat. I want the first element to be printed. 1 gets printed. If suppose I want the fifth element gets printed. If I want the last element, -1. Next, you have flat 10. We are doing flat, and similarly you have flat 10 also. So when coming to the flat 10, it creates, see, flat is an attribute which is an iterator, and flatten is basically which creates a new array. In some style also it can create. So for suppose I consider A is an array with 1, 2, 3 and 4, 5, 6. B is equal to A dot flatten. Print A first, print B. Initially, it prints as 2 rows and 3 columns. When you flatten, it prints in a horizontal and single dimensional. Similarly, I have another array multi-dimensional. I am considering it as 1, 2, 3, 4 and 5, 6, 7, 8 as another array. Suppose I say B is equal to A dot flatten. Order is equal to, in the Fortran order, print B. So it prints, see, when initially it prints in such a way like this. So it prints 1, 2, 3, 4. 3, 4 will be in the second row. Similarly, 5, 6, 7, 8. So when the order comes, first, second, this 2. In this way, the order comes. So order is 1, 5, 3, 7. That means 0, 0 matrix first it takes. Similarly, 2, 6, 4, 8. This is the order. It gets printed. Next, in general, So it prints in the general order. When I say like order A or the normal without you mentioning any of the order also, it gives the same output. So this is the flattened part. The next one is ravel. So when coming to ravel, ravel is something that returns a contiguous flattened array. So when coming to ravel, how do we work on with this ravel? Again, I consider the array. So in place of flatten, I give ravel. Print B. Ravel also contiguous flattened array, no? You get the flattened array only. Similarly, in place of flatten, again you go on with ravel for the multidimensional also. You get sequential 1, 2, 3, 4, 5, 6, 7, 8, so on. So this is what ravel basically do. Next, pad. Pad is something it attaches the values on both the sides of the array. Suppose if I consider array A is equal to np dot array 1, 2, 3, B is equal to np dot pad. I consider A, comma, pad width is equal to, suppose I say 3, and I consider mode is equal to constant. So whenever I say constant, constant over here basically means 0. Print B. It pads 3 zeros on the left side before it's starting the array, 3 zeros after 3. This is how it pads. Suppose if I say the same thing, in place of constant, if I give edge, the edge values gets padded up. That means whatever values are at the last, that values gets padded up. Suppose I say array is something 1, 2, and I say 3, comma 4. This is my array. np dot pad array. Pad width is something I consider 1, comma 1, comma 2, comma 2. Mode is basically constant. So B. One row on both the sides, two columns on both the sides gets padded up with. Now, if suppose I specially mention comma constant is equal to 9. 9 constant underscore values. 9 gets added in the padded place. So, 1 second. We have done array as array, arrange line, zero, empty, full. All these things we have done. We didn't do identity, diagonal copy. And resize we didn't do. These things had to be done. So the next one, we did end him, right? Let me consider an array. I say print a dot n dimensions, number of dimensions. So it's two-dimensional. Suppose if I say when then it's two-dimensional. It's three-dimensional. So the dimensions keep changing. Suppose if I say the same thing dot a dot shape, it says two arrays, two rows, and two columns. Now, similarly, if you want size, how many elements are there? 8 elements are there. So it give elements. Similarly, data type. D type. So it prints integer. Suppose I consider array A is this. Print A initially. Print A dot capital T. Transpose. Transpose is something which converts rows to columns and columns into rows. Next, A is equal to np dot I 4. Print A. It creates an identity matrix with optional offset. Suppose if I say I 3 comma 4, 3 rows and 4 columns. But for suppose if I say identity also do the same job. Hmm. Any other things that we have to do on I? Suppose, see, if I'm giving like this, it's printing like that. But what if I give 5 rows and 3 columns? It prints first 3. Then the remaining all, as there is no cross, only the cross, you would be getting the ones. As there is no cross, you would be getting only zeros over here. Suppose I say, mm, 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 mm. If you wanted to change the data type also, that also can be done. Suppose if I say 5, comma, D type is equal to complex. This cross, the diagonal, you would be getting as 1 plus 0j. Remaining all, you would be getting 0 plus 0j only. So this is I. Similarly, we are having diagonal, DIAG. So let me consider A is equal to NP dot DIAG 10, 20, 30. Print A. As I have mentioned that it should be diagonal, the 10, 20, 30 will be in the diagonal format. Suppose I consider an array. A is equal to NP dot array 1, 2, 3, 4, 5, 6, 7, 8, 9. What are the diagonal elements? 1, 5, 9. I wanted to print only those values. Print NP dot diagonal array of A. It prints 159. Suppose if I consider A is equal to NP dot array 1, 2, 3, 4. This is my array. Now, if suppose I wanted to print B is equal to NP dot DIAG of A, print B. It prints 1, 2, 3, 4. This is the thing. So the diagonal is done. Identity diagonal, you have copy. So how do you copy an array? Suppose I consider A is equal to, this is my array, B is equal to NP dot copy in the general way only. Print B. The same value gets copied. Suppose if I say B of 0, the first element is equal to 100. Print B again. The value gets modified also. Got it? So array creation functions, array, as array, arrange, line space, zeros, ones, empty, full, identity, diagonal. There is no ID over here. Diagonal copy, these were done. Array transformations, you have n dimensions, shape, size, data type, transpose were done. Array reshaping was done. We have to do resize, flatten, ravel also was done, pad also was done. Here I have to include pad, padding array. So we did reshape, we didn't do resize. We did flatten, we did ravel, we did pad, we did transpose, swap axis, move axis, squeeze. So we will just complete this 4. So when coming to resize, it changes the size of the array. If the new size is larger, values are repeated. Suppose if I say x is equal to, or else I consider A is equal to NP dot array 1, 2, 3, 4, 5, 6. So when I say B is equal to NP dot resize, I wanted to resize in such a way array, and I wanted to give 2 rows and 3 columns. It changes. Suppose if I say 2 rows and 4 columns, it again repeats. The next it keeps on repeating. It keeps repeating. So actually, previously we have done flatten and ravel, no? What is the difference between flatten and ravel? Suppose I consider A is equal to NP dot array 1, 2, 3, 4. B is equal to A dot flatten. C is equal to A dot ravel. I consider B of 0 is equal to 100. C of 1 is equal to 200. Print A. See, basically, flatten doesn't copy. Flatten copies, but the original array doesn't change. Copy. Original array doesn't change. But whereas for Ravel, view original array changes. This is the difference. Got it? So the next one. Swap access. So when coming to the swap access, again, I am considering an array. Let me give 1, 2, 3, 4, 5, 6. Print A. This is my array. So when coming to swap access, swaps two access of an array actually. So when I say print np dot swap access considering a comma 1 comma 2. Noodles. Let us decrease the dimension. So it should be attached in another dimension. So then when you give, you would be getting, let us not print this, that creates a confusion. So it prints the swap access. Next, Suppose I say, mm, this is an array, right? B is equal to np dot swap access array, comma, 0, comma 1. Print. So it prints 1, 4, 2, 5, and 3, 6. So vertical gets changed to the horizontal. Next, A is equal to np dot a range. Let me take some 24 values, reshape them to two arrays, 3 rows and 4 columns on the axis 1, print A. So it is printing two arrays with 3 rows and 4 columns separately. Each and every column gets printed. The same thing, if I print without axis 1, it prints this. Here also, you are getting the same values, but how you are getting this particular row, you are getting vertically. Nothing apart from that. Now, I consider swap access. When I say swap access, I re-execute this. On this, I wanted to do actually. B is equal to np dot swap access A 1, comma 2. So it prints in such a way 0, 4, 8, 1, 1, 5, 9, another one, so on and so go. Only each and every row values gets printed in a different line. This is about the swap axis. Next one is move axis. Move one axis to another position. So how do you move? Suppose I say A is equal to np dot zeros, 2 arrays, 3 rows and 4 columns. Let me print A first. Then I consider B is equal to np dot move axis A, comma 0, comma 2. Print B dot shape. So it changed the axis in 3 arrays, 4 rows and 2 columns. It just print the axis only. It won't give you the values. Next, let me consider squeeze. A is equal to np dot array, 3-dimensional, print A dot, let us check the shape first. 1 array, 1 row and 3 columns. Now I say B is equal to np dot squeeze A. Print B dot shape. 3 rows. Print B. It prints like this, but it considers in the format of rows only. So these are all another set of functions. So we have done reshape, resize, flatten, ravel, pad, transpose, swap axis, move axis, squeeze, transpose, d-type, size, shape, number of dimensions, copy, diagonal, identity, I, full, empty ones, zeros, line space, arrange as array, and array. 26 functions we have done on both multidimensional as single dimensional wherever it is required. So joining arrays, splitting arrays, mathematical functions, see, these are easy. Trigonometric functions and statistical functions, these things we will do in tomorrow's class. How many ever we can do, those things we can complete in tomorrow's class. But one small request from my side is, I want you to please join on time because you people are like joining till 7:15 and all. Please make sure that you join on time. So if you join 10 minutes before, what happens is we can sharp 7 o'clock if you join, we can complete another group of functions also. As they are very small things, even I require some good amount of time. So please make sure that you actually join on time. And all of you, please join to the session regularly. These functions are very important. When we are going on with this particular thing so-called statistics again, when we are explaining the statistical functions and all, again you will be like stuck in between if you don't listen the classes and all. Now you should know about the function. When you learn the theory, there you would be having a detailed understanding about what the function is all about. So here you have to remember these functions. Please make sure that you join on time.